Is power about having great strength, or having the courage to overcome great odds, to silence the doubt and the doubters, influencing others, or believing in yourself? Is power about having the ability to imagine what comes next, or an uncontrollable curiosity, standing together, or being brave enough to stand alone? Is power having knowledge, or just knowing who you are and what you have to give? Or is it an inner wisdom that comes with a long-held passion to learn everything about a subject, just so you can improve it? At Rolls-Royce, we recognize that power shows itself differently in different people. That's why, for us, our power is our difference, and our difference is you.
Good afternoon, good evening, good morning. Welcome from wherever you might be joining us to the Rolls-Royce Power Series. Today is the fifth episode where we're talking about imagination. I'm your host, James, and today I'm joined by Lauren and David. Welcome along. We're going to follow the format that we've had for a few of the last few episodes. We're going to have a bit of a chat for the first 20-25 minutes, and then we'll open up for some questions, and we'll do our best to try and answer them. So, to get us started, Lauren, would you like to introduce yourself? Tell us a bit about what you do and how you came to join Rolls-Royce.
Yes, thanks, James. Hi, everyone. I'm Lauren, and I am an electrical engineer. I first joined Rolls-Royce as a summer intern about 5 years ago now, and then I joined on the engineering graduate program. For the last year, I've been off the grad scheme, so we're working in what we call first substantive, so proper job in the same team. And I work in Rolls-Royce Electrical in the embedded controls team. So day to day, I do C++ coding. I design PCB hardware, circuit boards, and I also do some agile project management.
Brilliant. Awesome. Thank you. What about yourself, David? Do you want to give us a quick intro?
Yeah. Hi, everyone. I'm David Bell. I'm a technical project manager in Rolls-Royce. I'm an electrical systems engineer by background. And I've been in the company for about 6 years. I also started through doing summer internships and then joined through the graduate development program. And I've done a couple of roles around the company. So I've worked in our marine business, and then I've spent the last couple of years working in Rolls-Royce Electrical, developing battery-powered electric aircraft.
Brilliant. Awesome. Thank you very much. And just to round that off, so I'm James. I'm an engineering degree apprentice at Rolls-Royce. So I joined just over 4 years ago. I came into the organisation after finishing my A-levels. I joined as an intern during my gap year, and then I stayed on to complete my apprenticeship, and in my last year at the moment. So similarly, I've had lots of different placements in different parts of the organisation that hopefully you'll hear a bit more about in a bit. But at the moment, I'm working in our central technologies team, just looking at all the new emerging technologies that we can apply to our business. So awesome, we've got a good mix there. So looking forward to today. So I guess then to start us off, imagination is our topic for today. Lauren, did you want to tell us a bit more about that and what it actually means and means for you at Rolls-Royce?
Yeah, so imagination, I hesitated when asked to come speak about it today because for a long time I really didn't think of myself as an imaginative person. And I think that comes from, when I was in school, I was terrible at art. I loved maths and physics. You learn about the right-hand side of the brain, the left-hand side of the brain. I straight away knew I'm, an analytical, methodical person. I'm not arty, I'm not creative, I'm not imaginative. But actually, it's a bit more complicated than that. It's not an either or. And engineering and design, especially, are subjects where not only are there opportunities to be imaginative, you actually have to be imaginative if you're going to get the best result. So in work, kind of day to day, that there are two main places where I kind of identify seeing imagination. So the first one, I think, is what you typically think about with imagination, and that's the big picture idea of, okay, how can we make this better? Having the imagination to ask that question and think about that solution. And I'd say also being, believing and being a bit optimistic about it, grounded in reality. Yes, we understand the challenges, but imagining that there is a better solution. So sustainability, net zero, it is a big topic at the moment, and also, it's a big part of our future strategy. I'm going to talk a bit about electrical because that's where I work. So, and in the all electric space, we're looking at urban air mobility and commuter aircraft. But there's also hybrid electric, and that's really important for how we, continue to improve things in our civil and defence businesses. And then even beyond that, with this technology, we're looking to, pull all the levers we can for net zero. And that's looking at how we can support markets like marine, hybrid rail, microgrids through the Rolls-Royce power systems. Yeah, so a lot of really exciting things going on. And the other place that I see a lot of imagination, and I'm actually really inspired by my colleagues and how they show their imagination, is almost the complete opposite. So right down in the details of engineering work, and it's with the constraints. So there are lots of constraints in design, and actually I think that can really prompt and force almost creativity to navigate those constraints and overcome those challenges. So, completely different to engineering, but an example of that might be something like TikTok, where you have this really short time constraint that actually prompts really creative output. And then finally, the last thing I want to say about creativity is actually about the environment. So something that I think is really important is having an environment where everybody feels that they can contribute their ideas. I've been very lucky that I have always worked in an environment where, even as the most junior person in the room, I felt I could ask questions and contribute to discussions. And a good example of something that led to an innovation, but I wasn't trying to do that, is one of our senior experts. He was explaining to me, okay, we have this control card, and then we have two interface cards that plug into it. And I asked him, oh, why are there two? Why are they not just make them one card? And he said, oh, well, actually, we used to have two because of some historical application that we don't need to do on this project. So yeah, let's make it one. So having the environment for that to happen is really important. And the other part is having an environment that is supportive beyond the initial idea to actually execute and make things happen. So one thing I'm involved with is our mental health community practice. Now, I said to someone, it's World Mental Health Day, can I do a talk to our team? And they said, yeah, actually, I'd like you to do it to the global team. And then that talk then led to a community that's now been running for a year. So yeah, that's my thoughts on imagination and how it is kind of present in my job day to day.
No, brilliant, thank you. And that was a really good example there of the cards, because for me, a lot of the stuff that people think is really complicated, sometimes we've got really simple answers, and pursuing sometimes a really complex solution, sometimes the simplicity behind some things we do is really, really nice, and it all just clicks together. So brilliant example. Thank you. You talked a lot about Rolls-Royce Electrical, and I guess one of the most recent examples of where we've been pioneering with electrical has been the ACCEL program. And David, I think you were part of the program, weren't you? Do you want to tell us a little bit more about that and your involvement?
Thanks, James. Yeah, so I've spent the last few years working on the ACCEL program, and that's where we designed and we built an all-electric aircraft, and we did that to go and break the world record for an airspeed world record. And we did that in part to learn how do we develop batteries that we can use to propel aircraft, because all aircraft today conventionally powered using liquid fuels, fossil fuels. And we are at Rolls-Royce, we're considering all the different technologies, all the different alternatives to that, and how can we make air travel sustainable? Because connecting people, moving goods around the world, building bridges between peoples, they're all really valuable things. So air travel is a valuable thing, and it's worthwhile protecting that and finding a way of being able to maintain that whilst doing it in a planet-friendly way. So on the project, I was what's called the project safety lead. So I was basically tasked with analysing the design and understanding what could go wrong, and essentially all how the different components and the different systems could fail, and making sure that we had put in place controls or mitigations to make sure that those failures wouldn't happen. And really primarily to keep our pilots safe. So it was a single-seater carbon fiber racing aircraft that we built, and then the real focus of the project was developing a large battery that would essentially power the propulsion system for that aircraft. So on the project, it was Rolls-Royce, but we worked with other companies. So we worked with a small aviation startup company called Electrifly, and we also worked with a motor manufacturing company called YASA. So as well as developing innovative technologies, part of the project experience was just the way of working. So being in a large engineering company, there's standard ways of working that, working with Electriflight, who, being a startup company, much smaller team, different ways of working, much more agile approach. It was quite educating, and it really helps us understand how can we make our teams more high performing and go from ideas. So for example, we'd have meetings where we would discuss, we maybe need this component, and during the meeting somebody would on the computer they would use CAD, computer aided design, to draw up a component, and then they would be able to print the part, so 3D print the part during the meeting. We would test out the part in the lab, and then we would get it essentially manufactured in metal, and then it would be ready to go by the next day. So you could go from idea to actual part being used within 24 hours, which is pretty amazing stuff. During the project itself, there's really 3 key challenges that we had. So we'd set this goal of developing the world's fastest all-electric aircraft. We had a stretch goal of actually being the world's fastest all-electric vehicle, which is what we ended up doing. And there's a number of challenges. So it's propelled by a battery, but a bit like a rocket. The bigger the battery, the more power you get, but equally, you've now got to carry that battery around. So there's an optimal size of battery so that you've got enough power available so you can go really fast, but you're also not carrying that weight around. So that was one challenge we faced. The second was that batteries can catch fire. And so we had to think really carefully about how do we make sure the battery stays cool, and in an emergency, if it did catch fire, how do we make sure that that fire is contained and it doesn't damage the rest of the battery or cause any issues with the plane, and basically that it's able to continue to fly safely. And then the third main challenge that we had was really optimizing how we flew the aircraft. So when you're flying and you're changing direction, you're increasing the G-forces that the plane is experiencing. And if you've ever seen Red Bull air racing, where they take these racing aircraft and they fly really fast through these sort of pillars, and there's a lot of optimization done on how much acceleration the aircraft is experiencing, because that has a big impact on its speed. So we worked with one of our engineers who used to work for Red Bull Air Racing to really optimize how the pilot was flying the aircraft so we could really get it going absolutely as fast as possible. So that's a bit of a flavour over the kind of challenges that we faced in ACCEL. And I'll pass back to you, James. You're going to talk a bit about digital technologies, I think.
Yeah, no, brilliant. Thank you, David. It seems like you had your hands full with safety lead there. Some exciting challenges. Thanks. So I guess what I wanted to talk about in it, there's sort of a theme running through both of what you were speaking about there. These new ways of working, whether it be in agile or whether it be in distributed teams. For me, I joined Rolls-Royce wanting to be a mechanical engineer or being an aerospace engineer, and I'm doing my degree at the moment through my apprenticeship, and that's in mechanical engineering with aerospace. But throughout my time and the way the apprenticeship is structured and similar with the grad scheme is you spend small amounts of time in different parts of the organisation. And the biggest theme and reoccurring thing that I've seen is that we spend a lot of our time looking at new digital technologies, whether that be developing new apps and services, or that be trying to improve how we're working, quite often using some form of digital, new tool, new method, or new technology. And what really is interesting for me is how do we keep that sort of cycle going? How do we keep the right skills in the organisation, and how do we allow people to use these new bits of technology in a really positive way to add value to what we're doing, and not distract from the ultimately mechanical problem that we might be trying to solve. And we see this a lot in some of the new businesses that we're developing. So I spent a little bit of time working in the SMR business. That's the small modular reactor. So we're trying to essentially rewrite how nuclear reactors for sort of low carbon power are ultimately built and commissioned in a much smaller time frame. And while I was working there, it was all about how do we use digital better? How do we use it to automate manual processes? How do we use it to remove manual intervention in things? And that was everything from the supply chain, from sourcing your materials through to running the plant, through to the decommissioning phase. How can we do it in a more efficient way that allows us to focus on the difficult challenges, and we can take some of that burden away from people? All these new sort of exciting pieces of technology, the artificial intelligence, the machine learning, the coding, they're always going to change. There's always going to be new things. But to develop the right skills to be able to adapt and change and utilize those, that mindset and that approach doesn't modify, doesn't change. So for me, how do we embed that sort of thinking into an organization? And being quite a young person coming into the organisation and having some technology background that I learned through school or university was really useful. And as Lauren mentioned, you're always listened to in that environment, which I thought was really powerful. And having the opportunity to lead on some of those schemes and projects was for me really enjoyable, and also quite empowering to be able to lead in that sense. And finally, the final comment I'd make is that for me, imagination is, as Lauren mentioned, a bit of creativity. A lot of what some organizations try and do is just take their manual process and make it digital. Just pick up and plug in and play is a term that they use a lot. And that sort of digitization approach. What I'm really interested in is how can we recreate that experience? Customers are much more after not just making money, but how can they improve the experience for an end user? So how can we actually fully digitize a process and not just convert it so it's online, but rewrite it and rebuild it in a way that is much more customer friendly and is much more usable, and ultimately saves someone time, saves them effort. And you see this through smartphone apps, you see this through online banking or other bits and bobs, but how can we as a industrial technology company do that as well? But for me, that's what I'm excited about, and something a little bit different to the mechanical focus that a lot of my colleagues have, but for me is essentially the future. And I've been prepared through my apprenticeship, and I'm excited what the next couple of years have got in store. Awesome. So I think we've got a few questions that are already coming through in the chat. If you've got any, then please pop them in, and our other team will be sending them through to us. I'm just going to scroll to the top because we've already had quite a few. The first question we've got is, I noticed that Rolls-Royce is committed to a net zero aviation. Why net zero and not absolute zero? So I guess I'll take a stab at this, and I'll draw on probably some of the electrical expertise in the room. But I probably think I'm right in saying that technology for us to essentially completely electrify or completely remove the sort of the gas turbines that we've got on engines at the moment isn't around in the electrical space. I'm getting nods from from
absolutely.
Yeah.
Go
on,
right
David.
ahead.
Yeah.
So I mean, you've got a challenge where the incumbent technology, what we use today, fossil fuels, the liquids that they use, they're really convenient. You know, room temperature liquid that can store so much energy that we can take an aircraft and fly from the UK to Australia direct. So you've got this challenge of how do you essentially replace that experience with an alternative, and that really means that the energy source on board your aircraft needs to be as light and store as much energy as possible. So you talk about energy density, how much energy per unit volume or per unit mass. And if we look at fossil fuels and we compare them to the alternatives, so the technologies that we're developing, we can think about battery electric. So if you look at the energy density of batteries, they are 50 or more times less energy dense than fossil fuels. So you've got this huge challenge of how do you want to go a big distance, but without the energy to do it. And so you've got to think about these alternative technologies. So there's a lot of work going on inside the company and across the whole industry of these alternatives. So those are namely hydrogen. So taking hydrogen either as a gas, or if you cool it down to a really, really low temperature and store it as a liquid in a cryo-cooled system, that's an alternative. And that could either be combusted in a gas turbine, a bit like we do today. There's engineering work to be done to swap over from these liquid fuels to hydrogen. Or alternatively, it could be what we talk about as a sustainable aviation fuel. So that's where we chemically replicate the type of kerosenes that we use in aircraft, but we don't get them from a fossil source. So we produce those fuels by essentially extracting the CO2 from the atmosphere. So that the production process involves removing CO2 from the atmosphere. So when you burn those fuels, the same amount of CO2 approximately goes back into the atmosphere. So that's why you talk about net CO2 being zero, because you've removed the CO2 from the atmosphere, but we don't get them from a fossil source. So we produce those fuels by essentially extracting the CO2 from the atmosphere. So that the production process involves removing CO2 from the atmosphere. So when you burn those fuels, the same amount of CO2 approximately goes back into the atmosphere. So that's why you talk about net CO2 being zero, because you've removed the CO2 from the atmosphere by producing the fuel.
Yeah, and I think it's worth mentioning that there's no silver bullet when it comes to climate change. There's no one solution that's going to help us on that pathway. And for an organisation that ultimately our products are responsible for a considerable amount of CO2 emission and other emissions, it's a journey. And there are all these new different business ventures that we're exploring, and therefore we're trying to develop new products and new things. But as David mentions, it's something that we're going to have to bring the technology along with us as we go along.
Yeah. I see one of the questions that's come through is about the spirit of innovation. So our battery electric aircraft. So how do we plan to use this technology? So we've gone to all this effort of understanding how to make batteries in aerospace. Well, we basically see that there are some applications where batteries in aerospace really make sense, and there's a really good opportunity there. So for smaller aircraft, what you might call commuter aircraft, so ones with say 9 seats where you're doing short hops to islands, they can definitely use battery electric, and that would mean that you've got no local emissions. So there's no local emissions around the airfield where these planes operate from, and they're quieter. And then the others are urban air mobility. So that's where you've got electric vehicles that are kind of a crossover between a helicopter and a conventional plane. So it's like there's multiple rotors that cause the aircraft to lift up, and then it kind of transitions and then flies horizontally like a plane, and it can go from point to point. So because we see these opportunities with electric propulsion, we've actually, so we've got a civil aviation business in Rolls-Royce, but we've actually set up a brand new business, Rolls-Royce Electrical. And in that business, we're developing all these products to serve these new markets that we see. So different from the sort of traditional gas turbine markets in civil aerospace today.
Brilliant. Lauren, did you want to jump in there as well? Sorry.
I think that was a great explanation. The only other thing I'd say about the first question about net zero, not absolute zero, that I think is important to capture is, as Dave says, we have technology that is removing carbon in order to reach that point, which I guess you could describe as offsetting technology. But I think it's an important point that, our strategy doesn't include buying carbon offsets, which is a different a different thing. So yes, we have technology that is removing carbon in order to make that work, but we are looking to do this through technology rather than buying offsets.
Yeah.
Brilliant.
If you think of different industries and the challenges that they have on achieving net zero, aviation is one of the hardest, simply because of the challenges we've described so far. The technology needs to be really, really light, and that means you need this high energy density. Whereas, for if you take automotive, for example, cars, batteries can be heavier. In fact, it's even an advantage in a car to have a heavy battery on the floor, because that improves the handling quality. But those same batteries wouldn't be good enough for an aerospace application. They would need to, the volume and the mass that they need to be is lower.
Yeah. Brilliant, thank you. We've got another question. Lauren, you mentioned hybrid aircraft, and I think David was touching on it there as well. Can you tell us a bit more about how Rolls-Royce will achieve this, and what kind of fuel source Rolls-Royce is thinking to use?
Yes, I'll start with the fuel source. I'm sure we'll get into this in a bit more detail maybe from yourself, James. So as David said, sustainable aviation fuels is a key aspect of our strategy for aviation. On hybrid aircraft, we've been testing our megawatt machine, which is for a hybrid solution. So with hybrids, there's two types of solutions. So there's a series and a parallel. And in one, you essentially have the engine operating, but also running a generator which can supply additional power. And in the other, you actually have it the other way around, where you've got an electrical machine which is able to help power the engine. So yeah, lots of exciting work going on for that.
Brilliant. Yeah. Awesome. David?
Hybrids, so that kind of technology where as we're improving the battery technology that we have today, it's a good way of making reductions now, a bit like with automotive, when we saw at first the introduction of hybridization, and then we're seeing that really transition away, taper away as we move to more all electric. So yeah, we see hybrid as a good way of getting reductions now with the technology that we're developing right now, and not having to wait some distance some time into the future for batteries that are even better than they are today.
Yeah, and I guess just to pick up on that first thing that Lauren mentioned about sustainable aviation fuels. So this is a big thing that's here now. So these have started to be produced. These are fuels that don't come from fossil fuels, so from sustainable feeds. So they could be from plants or waste oil or other sort of forms. There's quite a few out there, quite a few different ways. At the moment, it's quite expensive and quite rare, so it's not used very widely. But there are even some airports that insist on some SAF actually being used for the flights that are leaving it, and that we've tested 100% SAF usage on some of our aircraft. And I think from the end of this year or early next year, we're looking to use it on our testing sites, using at least 10% SAF in our engines that we're testing. So we're being a bit more sustainable while we're doing our development work as well. But SAF is really going to be a game changer going forwards as production starts to ramp up. And for our products, it's about making sure we're akin to that and we're able to use them as the supply starts growing. And I know we're working with some of the fuel suppliers to look at how we can best support that as well.
Yeah, so as you say, James, with SAF being, kind of rare and more expensive, it's, even more important to reduce the fuel use. And so that's, really where electrification, whether that's efficiency or hybrid, can assist with that move as well.
Awesome. Right, we'll look for another one of our questions. So David, I think this one's pointed at you, but what comes next after ACCEL? Is the developed technology easily scalable for bigger aircraft?
Yeah, that's a great question. So we took on this challenge to develop this battery, but clearly our business model is now not to go out and sell racing aircraft. That's not really a scalable business model. So
instead, Red Bull, Rolls-Royce, soapbox, not soapbox,
F
racing, air racing, yeah.
If Rolls-Royce are willing to pay me to do that, then I'll sign me up today. But I suspect we've got an eye to do something else. So yeah, we're really going to be focused on commuter aircraft and eVTOL, so these electric vertical takeoff landing vehicles. So that's really where all the learning that we got from how to make that battery for ACCEL, that really comes to bear. So we've got a really good understanding of how do we instrument a battery. So there's the battery that we had on board our aircraft. It's actually comprised of cells, a bit like AA batteries. If you think of a AA battery, a little bit longer, a little bit chunkier, 6,000 of those. So 6,000 of those cells all together in a big mechanical assembly, all connected together electrically. So that's something that can be scaled and can be sort of modified. And so we've learned a lot about how do we need to capture data from that, so the temperature data and the voltage data, but also about how to make sure it stays cool. So if you're drawing lots of power from the battery, the cells all get hot. So you've got to think about how do you pass a liquid close to those battery cells to keep them cool, but obviously making sure that you're not electrically affecting the batteries. So some real challenges there and lots of learning that we've taken from the program. And so really that aircraft existed to go flying for a few months so that we could go break these records. But the challenge really is to take that learning and say, okay, that was great. How do we put this into a product that we're going to give to a customer and they're going to operate it, all day long over its whole life? So there's a whole load of learning that we need to, go out now and develop onto how do we turn that demonstrator into product.
Awesome, brilliant, thank you. Next up, we've got what challenges are there for large-scale manufacturing or battery electric propulsion? Now, I don't know much about this. I'm going to throw over to you guys.
So something that we're very cognizant of the moment is that real challenge. So as an organization, we've done lots of thinking about how do we design batteries, but really we're getting into that next stage of how do we manufacture them. And in aerospace, when you get on an aircraft, you expect with just about absolute certainty that you're going to arrive in exactly the same condition at your destination. It's like getting on the bus. You're not thinking something might happen to me as I make this journey. So with electric aircraft, even though we've got all this new technology, we've got to be just as confident in that technology that it's just as safe as the conventional technology. So we go through a process called certification. So that's where we go to the authorities, and we basically have to make an argument to them and prove to them why are our systems safe. So that's a lot of the effort we're going to right now, and that applies across how we design our products, but also how we manufacture. So when we set up a factory to develop batteries, we've really got to prove that what we're doing, it's all to a very high quality, and that we're, consistently, the products will perform exactly as they're intended to. And so yeah, you've got these really high demands, especially in aerospace. And so it's a real challenge because, there's a lot of learning that the industry in general has got about manufacturing batteries in automotive. But, if something goes wrong with a battery in a car, you can just pull over to the side of the road and get out. But if it's flying your plane, there's not really an option to do that. So the consequences of something going wrong are much higher. And that's why you need to be even more certain the technology is very, very safe.
There's no laybys at 30,000 feet, as someone told me when I joined Rolls-Royce. I'm sure they told you as well.
Very good phrase, absolutely.
Brilliant. Was my next question gone? Has Rolls-Royce engaged with the circular economy philosophy when it comes to inputs and outputs? I'll take a stab at this one to start with, and then see if Lauren and David's got anything to add. I think, yes, I think if you look at where we're going sustainability-wise, there is a little bit of a, how can we make this all fit together? Where does it all come? And I'll take the small modular reactors as an example. That obviously, looking at the power generation, how can we do it in a low carbon manner that is sustainable and will last us the next 100 years with various different plants across the world? Things like that are really, really useful because SAF production, for example, is incredibly energy intensive. You need a lot of energy to be able to actually create SAF up front. Yes, it's using sustainable feed, but you need a lot of energy to actually create the fuel. So that would be a good example of where we're thinking, okay, we need a lot of energy to feed the production of SAF. SMRs would be a good example of that. We're then going to need a lot of power to charge all of these batteries that we keep talking about. How can we do that in a better way? Again, the SMR program is that creation element. Then the usage of that, and then we were talking about how do we then remove carbon from the atmosphere as well. So I think, yes, that's the direction that Rolls-Royce is going. How can we make this a more sustainable and ultimately circular process, and also through our supply chains? How can we make sure that the materials that we're gathering for all our manufacturing processes is sustainable and is working well and is right in that sense? I guess that's my attempt. I don't know, Lauren or Dave, if you've got anything to add to that.
Yeah, I agree. And I think in the net zero report, it mentions the supply chain and the value chain multiple times because we don't operate in a vacuum. We need the holistic system, everything to kind of come with us on this journey. And I was lucky enough to go to COP26 and represent Rolls-Royce on our stand in the green zone. And it was really amazing to see all the other companies there engaged on this topic as well, to know that, we are doing everything that we can and that they are also doing their parts to enable us to reach this goal.
Interestingly, on the circular economy, it's actually something that's really quite embedded in the company already. So in part, that's because for our gas turbines, which is one of the biggest products we have, they have to be able to operate at really high stresses and really high temperatures. So there's some quite exotic metals as part of those gas turbines. So really, we recycle a lot of the portion of the metal, especially in our manufacturing processes. So really that mindset of recycling material is really built into the way we make and design our products right now. If we think of batteries and all we've said about how in aviation you've got these the sort of the highest demands of how energy dense and how power dense batteries have to be. As you use a battery, the amount of energy it can store actually reduces. So we've all had that, with your phone, where you've had it a few years and, suddenly the battery just becomes rubbish. It can't quite store as much energy as it used to. It discharges really quickly. So that happens with all batteries. So there reaches a time where a battery that's designed for aviation, it's no longer good enough. It can't store enough energy. But that doesn't mean chuck it in the bin. That does mean, however, that battery could, and we're thinking of these different business models now. How could we reuse that battery? Could we use it for a different application where actually the amount of energy it stores is perfectly good enough? Could be used, for example, in a maritime application where ships are big and heavy and bulky, so there's a lot more volume and weight capacity that a battery can take up. So yeah, it's a general mindset across all of our products. How can we reuse not just the materials, but actually the products themselves, when traditionally they might have reached their end of their life, but could those products be reused in other applications instead?
Yeah, no, definitely. Next one is on digitalization. How do you think you would affect the employees working at Rolls-Royce? What would you do to ensure they still feel valued and not replaced by technologies like AI and big data? So I think it's a really valid point. I think when we talk about digitalization and changing the ways of working, what it's really important to sort of understand is that what we're interested in doing is how do we make the simple things automated? How do we make our time more efficient? And how do we better utilize the systems and the resource that we've got? When we're talking about big data and machine learning and all these great things, they're really good at doing the sort of the manual tasks, the simple things. They can do some wonderful things as well. But the focus is how can we make our time better utilized? How can we remove the boring, laborious tasks that ultimately, if you get a human to do, they're going to do it, but they're probably going to make some mistakes. They're probably not going to be as good at it, and they're probably not going to be as fast at it. So that's the first sort of element. The second element is how do we make sure that those people that might have been doing those tasks are then upskilled to then have the knowledge and the ability to go and use their time better and go and focus on the really difficult, the really challenging, and the really hard, exciting problems that we've been talking about. And for me, that's really interesting. How do we make sure we've got that human element? And what it does is it makes those human skills so much more valuable. So the creativity, the imagination, which we're talking about today, all those human traits that will become so much more valuable. The great thing about big data and data analytics and visualization is you're trying to build a story. You're trying to make a better informed decision. And how you use that data to either tell a story or make a business decision or make an operational decision, whether we should divert this plane to that place instead of that place, or we should load it with this fuel or this fuel. How do we make better, more informed decisions using more data that we've got available? And as we move forwards, we're getting more and more data all the time. We're getting more and more tools and systems all the time. How do we make better use of it, and how do we make sure it's still adding value to what we're doing? That's sort of my thoughts. I don't know, Lauren or Dave, do you have anything to add to that?
Yeah, I think it's just trying to find the right solution for the right problem, and playing to the inherent strengths. And well, to be honest, the right solution for the right problem, I think you could say that about the entire net zero strategy.
Yeah, no, 100%. Brilliant. So we've got one sort of about the future of jet engines. How do you think the future of jet engines will evolve? Will we be using electric for short hops, SAF/hydrogen for medium, and kerosene such as Jet A for long haul? or will we go to SAF hydrogen for the long haul too and eliminate the kerosene fuel? David?
Yeah, it's a really interesting one. And I think part of the exciting thing about aerospace is how we still haven't quite figured out the answer to that. So we've got ideas. So I think that the current thinking in industry is that for long haul, so SAF and kerosene can store just as much energy. So we talk about SAF as being a drop-in fuel. So that basically means that with very, very minor modifications, aircraft today can fly using SAF. So it's possible to take aircraft that are already in service and fly them with SAF. And that's really important because if you think about, we're in 2022 now, and we want to be net zero by, latest 2050. How do we make sure that all of the products that are in service today can be net zero? So if we sell a brand new aircraft today, it's going to be in service for maybe 30 years. So that takes you beyond 2050. So we need to find some way of decarbonizing that aircraft, as well as newer aircraft that will be released between now and then. And there's a possibility that they could be powered using different technology. So SAF is a really important part of decarbonizing today's aircraft. It is possible to still use gas turbines, but with a different type of combustor and different storage. So this cryo-cooled storage to store hydrogen. So hydrogen is a liquid fuel. There's been a number of studies done. So in the UK, we've got the Aerospace Technology Institute, and they did a study over the last year. And one of the outcomes with that is they came up with a concept for an aircraft. They basically demonstrated that it is possible to have an aircraft that could fly from London to San Francisco and be powered on liquid hydrogen. And it could carry, I think it was 250 people around that. So it is possible to have large aircraft fly long distances. But in order for that to happen, you've got to develop the technology in the gas turbine. You've got to develop the cryo cooling for holding those fuels within the aircraft. But then there's that wider challenge. We can really see an analogy to that with automotive. So whilst everybody's got petrol stations all around the world, it's all very established, we're now going through this exercise of making sure we've got enough charging infrastructure. So that really also becomes the challenge in aviation, where you may have all the ability to transport jet fuel around, but what do you do if the fuel must be at 20 degrees or 20 Kelvin? It needs to be minus 250 degrees. It's got to be super cool, and that means you need a totally different infrastructure. So that's where you need much broader thinking about, right, we need to develop the vehicle, but we also need to be able to produce the fuel in enough quantity that we can power all these aircraft. But then we need to transport it. So these are all big challenges and really big, exciting tasks that we're all thinking about and spending our energy on. Yeah.
Brilliant. Awesome. Thank you. Next one. Is there a reduction in the overall performance when using these bio-derived fuels due to the lower energy density? How do you alter the gas turbine to accommodate them? So I think Dave's just spoken there about some of the modifications you've got to make for hydrogen, and SAF at the moment is sort of a drop in and go. And the great thing about SAF is we can use it in different blends. So you don't just have to use SAF or kerosene. You can use it in 10, 20, whatever, up to 50% for some fuels at the moment. You can use SAF just on a commercial flight. And as with anything in aerospace, it's about trade-offs. How do we optimize? How do we, if we're going to use SAF, reduce the carbon footprint? How do we, yes, there might be a slight difference in energy density depending on the exact makeup of that. But how do we optimize for that depending on the route, the flight, what's going on? So it really depends on a whole range of factors. And I guess it's just another challenge for us to try and work out.
I think it's a little bit like the renewables industry. you think, where was renewables 10, 15 years ago, where we were making wind turbines or solar panels in really low volumes, and the cost was enormous. But with a lot of investment from government and industry, we're able to bring that cost right down. And now you can see that the technology is so widely used, and it's cheaper than the alternatives. So I think that's really where we can ultimately get to. But you need to start using it at low volumes whilst it's expensive, in order to increase the amount of production and therefore bring those prices down. So yeah, with today's aircraft, they're certified, so they're allowed to fly with up to 50% of SAF. But as a company, we've actually we have a flying test bed. So that's basically a 747 aircraft that we use to test new engines or new technology. And we've flown that aircraft with one of the engines entirely powered by SAF, because we wanted to understand how does its performance compare to the other engines, which were powered by conventional kerosene. And so we've got a lot of learning from that, and there's a lot of thinking about how can we do we need to make any modifications to how we design our engines or use them.
Yeah, to go back to the question that was kind of asking about electrification for the short range, and then SAF and hydrogen for the medium and long range. I think hydrogen as technology is at an earlier stage in the technology process. So with SAF and electrical, it's quite clear to me where they will fit and what we'll be able to do with them in line with our strategy. With hydrogen, there's been quite a few questions. So yes, we do have teams working on hydrogen. It is a really exciting opportunity for innovation. But because it is at that earlier stage in technology and overcoming the challenges, we're not quite sure yet what that will look like, or how it will really come into play. I think I saw a question about hydrogen fuel cell. I just want to mention our power systems have a hydrogen fuel cell product currently for land-based applications. So looking at emergency supply for hospitals or data centers and that kind of thing. And it's a really good opportunity for us to learn about that technology and then see how we can build on that to operate in tougher environments.
Absolutely. Yeah, we're doing some thinking at the moment of, could you use fuel cells in aircraft, and what would be the limiting factors for that? So if you think of a battery and how it can convert all that chemical energy that's stored inside it and convert that to electricity, it can do that at a really high efficiency, over 90%. If you think of a fuel cell and it's taking the chemical energy of the liquids or the gas, hydrogen fuel, and combining it with oxygen, and the output's water, so you get this clean output, but it actually produces quite a lot of heat. It's maybe say around 50% efficient. So if you're producing lots of power from your fuel cell, you're also producing lots of heat. So that one of the big engineering challenges is, right, how do you manage that heat? How do you make sure that you can keep the fuel cell nice and cool? So as Lauren says, the technologies are less developed, and so there's work to be done and lots of opportunity potentially in a brand new market. But we've got to think about the engineering and how do we develop these technologies. And there'll be lots of creative thought required to make that possible, because we'll have to think of new solutions for these technologies.
Awesome. Another question here on a slightly more digital front about the intelligent engine. It's truly exciting technology, and it's interesting to know how Rolls-Royce has approached its creation. Could you tell us more about the innovative ways behind the development of the intelligent engine? So the intelligent engine, for those who might not have come across it before, is essentially building what we call a digital twin of our engine. How can we create, we have a physical product, but how can we create its equivalent into the digital space that is fed with the exact same data as that physical product experiences. So we simulate it flying however many flights or cycles or whatever through the similar conditions that it's going through. And by having a digital representation, it allows us to predict all these different things about this engine. It allows us to do sort of predictive maintenance to say, okay, if we play this scenario forwards and it's flying this route for the next year, what is going to be the wear on all these different components, and can we predict when it needs to have its maintenance cycle? Can we optimize when it needs to be serviced, or when it needs a new pump, or whatever that might be? But when it really comes into its own is when you have unanticipated scenarios. So you have an issue in flight with a component. You can look and understand from your digital twin, how might we be able to fix that? What could be the issues? What is the data showing us? Can we almost automatically dispatch a new part to meet that aircraft when it lands at its next airport? Or in scenarios like COVID, where we had the grounding of a lot of aircraft, that allowed us very quickly to understand, okay, what's going to be the maintenance impact of this? How can we optimize our maintenance schedules to take advantage of this period of grounding? How can we best advise our customers to look after the data around us? And it comes back to what I was talking about earlier. How can we make better, more informed decisions about our products, and how can we understand that? And really interesting with Rolls-Royce, we monitor all our aircraft engines while they're in the sky, and we help advise our customers on different ways to use them. We can even get down to sort of individual pilots and individual aircraft recommendations to say, well, when this plane took off from this airport last week, it wasn't using the optimum amount of thrust, and that took this amount of life off this component. So when you next do that, do this or this. And because they're the customer's products, that they're going to want to save money and save time and save effort. So really, the intelligent engine is the term we give to that digital twin, and that sort of ecosystem, we call it, of different products that go around that. And for me, it's really exciting, as you could probably tell, about how we replicate what we're trying to do in the physical world, but digitally. Yeah.
Yeah, absolutely. And on our electrical technology, it's not an engine, but that concept of digital twin has been really beneficial. And our team is in discussions with the relevant teams and people to make sure that we have the same for when electrical propulsion systems go into service.
Brilliant, awesome. We'll just to have a look at one or two more questions. I appreciate the time. So there's one here. Are you considering the possibility of integrating solar panels similar to the Solar Impulse project in addition to batteries, a secondary power source, or will this bring more problem than benefits? So I have no idea about this one.
So it's an interesting one. I think really it's answered because, large aircraft, even small aircraft, they need a lot of power to move people around. And so the amount of power you need, you really are dependent on an energy source that can deliver lots of power. So for aircraft, solar panels wouldn't cut it. That's why we have to rely on other sources. So like liquid fuels, essentially. But for electrically powered aircraft, it's quite possible that the electricity that was generated to charge your battery, that can come from sources, for example, solar. But yeah, you wouldn't carry those on board because that would just be additional weight. And a bit like our rocket analogy earlier on, you've then got to carry that weight around the whole time. So it doesn't make sense in that regard.
Yeah, well, one of the big challenges as well is, as guys were saying earlier, safety is really important for aerospace, and you have to plan for kind of the worst case scenario. So where you have something that is intermittent and you don't know exactly how much solar power you might get on a given day, that makes, to get that certified, you have to be very cautious and have additional technology then as well for when it's not sunny.
Yeah,
great point.
Very good, and can't fly at night either. Very nice. And just on the topic of solar energy, and I saw there's another question about solar panels and charging of aircraft in electric aircraft and batteries. One of the other things that Rolls-Royce is involved in is what we call microgrids. So these are really small based grids that allow you to capture energy through things like solar or hydrogen or fuel cells, and allow you to store that energy for when it's used. So you can use these in rural areas a lot easier than connecting them up to the mains. So that's one of the other exciting businesses that the power systems team are involved in as well.
Yeah. So one of our sites in the US is now powered by a microgrid, and I believe our site in Bristol is due to become our first microgrid in the UK.
It's pretty cool stuff, when you've got all these different renewables on site, solar panels on roofs and that sort of thing. Sometimes it's just not necessary to be connected to the grid, and it can be a sort of quite a useful solution for communities that are quite remote. They can have local generation, and it's all connected together, and let's have use of renewables. They can be shared around the community, but not needing all that big infrastructure to get a connection into the national grid.
Awesome. Well, I think we're probably going to call it about time there. My apologies, we didn't manage to get through all of the questions. I know there's some great ones in there, but hopefully we've made some good headway with talking a lot about both sustainable aviation now, as it is in its current form, but also where we're going in the future and some of the places that we're thinking. I guess just then for a final thought from our panelists, we talked about a lot today, from electrification of current projects with the ACCEL through to, as I say, where we're going in the future. I didn't know, David, did you have a final thought you wanted to leave us with from your experience?
Absolutely. No, cheers. It's just a really exciting time to be an engineer. We've got this huge challenge ahead of us, but that's a really big opportunity for us to think of new ideas to solve all these challenges. So I'm just really excited that the period of my career is going to be over this time where we've got to achieve net zero, and so aerospace is a really great sector to be in because we've got some of the greatest challenges, and so we'll have to come up with some extra special solutions to meet that challenge.
Brilliant. And Lauren, a final thought from you?
Yes, I think I'll bring it back to the theme of today, imagination, and say, especially the kind of early career stage that the audience is, don't be afraid to ask questions. Especially it's not always easy in certain environments. I remember when I first went to university, I found it much more daunting than when I was in school. But actually, now that I'm in work and have a bit more experience, that's my one regret, is I would wish that I did ask more questions. So yeah, ask more questions. You don't know what idea it might prompt.
No, brilliant. Thank you. And from me, I think very much echoing both of what Lauren and David said there. This is a really exciting time. Rolls-Royce really has the potential to be a thought leader in this space and actually lead the world in terms of sustainable power and what that means for all sorts of different markets. It was a really exciting time, and as a young person in a big organization, feeling like we can actually contribute and actually be involved in that process, for me, is really exciting. So with that, we'd like to thank you very much for coming along to this. Hopefully you've taken something useful away from it or enjoyed the hour that we've had. We'll be sharing a link to the career site, so you can go and have a look at the career site and find out a little bit more about opportunities at Rolls-Royce with the early career schemes. We've also got a link to the Power Hub, so you can go and have a look at all the other episodes if you've missed any of those. You can register for the next event, which is on Curiosity, which is in the future, and you can find out some more behind the scenes information and have a look around the rest of the careers site. So with that, I'd like to thank you for coming and hope you have a lovely rest of the day.
Thank you.
Thanks very much.